course, quick who am I? As was mentioned, I am a big data engineer at Bloomberg LP. And the reason that we got interested in Airflow is that my team's job is to kind of make life easy for data scientists, reduce barriers to entry, offer tooling to make their lives simpler. And scheduling is a very important aspect of being able to see your ML jobs running, abstract away a lot of the complexity of those jobs, and have monitoring for when your models are or are not working.
And I'm Seth Edwards, as she said, staff software engineer, and I work on maintaining a lot of our Kubernetes infrastructure, as well as architecting a lot of our new big data initiatives. We went with Airflow because we previously outsourced a lot of our big data projects, and we're currently bringing them all back in-house, so we were looking for something to help us with the scheduling and maintaining that.
So a quick overview of what is Apache Airflow. Airflow is a workflow scheduler that was developed at Airbnb, and it is a continuation of the concept of configuration as code. So unlike systems like Uzi or Argo, where you have to write out your dependency graphs as either YAML or XML, where it's not a very natural process, Airflow allows you to use a simple Python library to define the tasks and the dependencies and programmatically design workflows. It has a very active open source community with native integrations into things like HDFS, Apache Spark, AWS, and GCP. To begin, let's look at a very simple Airflow DAG. There are two main aspects that a user of Airflow needs to know about. The first of which being the idea of an operator or a task, and then this function called setUpstream. So by using this setUpstream function, you can define a task which is a bash request, a bash command, a Spark job, a Spark submit command, and set the dependency so Airflow knows, can greedily decide to queue up your tasks based on whether all those dependencies have been met. When you use Airflow, you actually get a lot of really valuable feedback information for free, such as a UI where you can watch your DAGs running in real time, as well as access to historical data and to logs. You can also define your own retry policies and emails for alerting. And these are a few other things for the UI aspects.
So when my team got started with this whole initiative, in addition to the infrastructure that we're trying to bring back in-house, we also had a lot of ETL-like scripts that were going unmaintained throughout the company. A lot of them were just running on dedicated EC2 instances that didn't really have a maintainer. So they didn't really have a lot of operational accountability. They didn't really have any observability, and they were also missing regular security patches and things like that that we normally would be concerned about. There were a lot of failures that would happen in the scripts, and because we were lacking this operational accountability, we didn't know about the failures, and we would find out about this from probably like a Slack channel message from the people who relied upon them in the morning the next day, which wasn't the best way to handle it. So when we got started, we evaluated a few different projects. We also evaluated Luigi, we evaluated Argo, but we ended up sticking with Airflow, which was our original idea. And that was because we really need to handle a lot of complex DAGs, a lot of complex dependencies. And when we saw how the DAGs were implemented in Python, it was just very natural for us. We have a lot of Python in-house, so that made it a good choice. And then obviously, we wanted to leverage the Airflow community. There's a lot of existing operators, a lot of existing sensors that are already been created, so we just have to just configure them. We can lean on code that other people already have had running in production. So for a lot of the basic scripts that we had, we were able to convert those in about less than a day. And for a lot of them, we haven't had any of the failures or things that we've experienced previously since then. So here's an example of one of our just basic DAGs. This is actually one that started out a lot more complex, but we were able to refactor it and push a lot of the complexity off to Amazon. This is actually running Apache Spark and then puts a lot of the results into S3. So right now what Airflow is doing is it's just making calls to APIs and then waiting for results to happen. It's not that complicated. And then if we look here, we have one that's a little bit more complicated with a lot more moving pieces of removing things from databases and then adding things back in and et cetera. So it's been able to handle that, no problem.
So by show of hands, who here has used Kubernetes before? Great. So decent number of people, but I do see some hands down, so I'm just going to do a very quick overview. Kubernetes is a container orchestration platform. So the same way that Docker can abstract away a single machine through things like virtual ports, Kubernetes can actually abstract away entire cluster-based configurations. So you can have things like service discovery, scaling, and load balancing done for you. You don't have to know exactly what machine things exist on. But for the sake of how we're using it in Airflow, consider Kubernetes as a pool of resources with a very simple API that allows us to dynamically launch complex deployments. When we at Bloomberg looked into how we could help the Airflow community, especially in terms of Kubernetes, we wanted to consider what the biggest benefits Kubernetes brings and how we could incorporate those into Airflow. And the two big things that we determined were dynamic allocation and flexibility of deployments. For the flexibility of deployments, we've created the KubernetesPodOperator, which allows users to launch arbitrary Docker containers through Airflow. And for the dynamic allocation, we created the Kubernetes Executor, which we will go into further down in the talk. So the Kubernetes pod operator allows users to deploy arbitrary Docker containers. And what it allows you to do is offload a lot of the dependencies and a lot of the complexity of running any task out of Airflow. So one of the users on one of our Slack channels kind of put it nicely and said, it allows Airflow to focus purely on orchestration. This is an example DAG of using the Kubernetes pod operator. The idea here is that one of these was made to pass and one of these was made to fail. The first task is just Ubuntu with Python in it, and it's able to run a very simple Python command, while the second one is just vanilla Ubuntu with no Python. So the idea being that you could actually create in your CI/CD pipeline, you can create exactly the environment you need with only the dependencies to run that one task, and then have use static tagging to be able to have easy rollbacks, easy deployments, and ensure that you always have exactly what you need to run a single task through Airflow. When it came time to actually look into the Kubernetes Executor, we actually did some interviews with users who have been running Airflow in production and kind of wanted to see what some of their pain points were and whether we could address those pain points. And the main pain points we heard of were essentially that running Airflow using some of these other executors involved having a static Airflow cluster, as well as having a multi-step setup process where you'd have to create things like a celery queue or work with Redis. And we wanted to see how much we could simplify that. The biggest issues that people were running into with these static allocations were oversubscription and undersubscription, where you might have a case where at midnight or at noon, all of a sudden 20 different DAGs kick off and you get flooded with requests and flooded with tasks to run. And this can be especially problematic if you have really, really strong SLAs where the next run of that DAG might be triggered while the last run is still waiting in the queue. The second problem is underutilization, where let's say you ramp up the size of your Airflow cluster to meet the demands of those hot points, and then afterwards, for the rest of the day, you suddenly have this Airflow cluster sitting unused, taking up cutting into your Amazon bill, wasting electricity, and wasting machines. So when we created the Kubernetes Executor, we created with dynamic allocation in mind. We also were able to add task-level pod configuration and fault tolerance. And the way that the Kubernetes Executor works is that you only need to deploy a single pod. And that pod contains both the web server and the scheduler. And when you run DAGs, for every single task that you want to create, the Airflow scheduler will actually ping the Kubernetes API and launch a pod to run just that one task and then die. This means that at points of high traffic, you can expand out the cluster as much as needed to run all those tasks. And then once all the DAGs have been completed, it will shrink back down to a single pod. Because these pods are being launched dynamically rather than in a static cluster, this also gives us the flexibility to actually define what we want each of these tasks to contain at runtime. So we added an extra field to being able to launch an operator called the executor config field. So if you have one task that is doing stochastic gradient descent in SciPy and a second task that simply launches a Spark job externally and monitors it, those are going to have very different needs in terms of memory and CPU. So we actually offer the ability to use a piece of the Kubernetes API to define the size of the task you are launching. We also give the option where you can pick the Airflow image you want to run. So this is especially valuable if, say, you want to bake in the DAGs into your Airflow image. And so as you're running these tasks, you have a full guarantee that even if you release a new version of Airflow, the DAG that is currently running will still use the version of Airflow that was available when it was launched. And finally, as a kind of cool security feature, we're starting to work in service accounts, where let's say you have a DAG where one step speaks to AWS and a second step speaks to GCP. We wanted to offer as much isolation as possible, so you can now define that one task only receives the keys to your AWS account and the second task only receives the keys to your GCP account.
Okay, so when we got started with the project, like I said, we already had an existing Kubernetes cluster that we could take advantage of. We did debate whether we should go ahead and try to move to the Kubernetes Executor or go with what a lot of other people were already running, which was on dedicated EC2 instances. But we went ahead and decided that we wanted to move it into Kubernetes because when we were able to take advantage of the Kubernetes Executor, we didn't have to do a lot of the upfront planning for capacity, AWS EC2 instance types we needed to use. We didn't need to think about a lot of the operational problems that we would encounter because a lot of that already we have set up inside of Kubernetes. We already have our observability stack set up. So we're able just to start writing DAGs immediately once we have the install and start delivering a product much faster and not have the ramp up time of all the observability. We also had a lot of time-sensitive jobs, and we wanted to make sure that we didn't have to focus on keeping an eye on the back pressure that could fill up in the scheduler. So as long as we're able to have enough cluster capacity, we're able to keep launching these jobs on time. So with all of this, we do have a lot of observabilities that we just inherited. We run Prometheus for metrics, and we run Elasticsearch for logs. We'll look at the Prometheus here. Basically, we just get an overview of the cluster capacity with Prometheus and Grafana together. We already have dashboards around that. Anything that we deploy to Kubernetes, CAdvisor and Node Exporter are already pushing metrics out there. So some of the things that we looked at early on when we were experimenting with Airflow was, container startup time, pod startup time, things like that. And then moving on, we have the Elasticsearch and Kibana infrastructure that was already existing. We use FluentBit to ship all of our logs, so anything that gets deployed to Kubernetes, FluentBit's already pushing those logs up there. It's important to note that this is really only for the web and the scheduler logs. The worker pods have their own. So the worker pods, they actually go to S3. So Airflow has its own dashboard that's purpose-built, and you get to see a lot of the DAG-related time information in here, landing times, things like that. The other important thing is that we have the logs from the actual worker pods themselves, those go into S3 and they're made available by this Airflow dashboard. So it might seem counterintuitive to have logs going to different places, but actually everything that the author of DAGs need to be worried about in our organization, those are all available in that dashboard, whereas the rest of it is probably more operational and is of the concern of people running the Kubernetes cluster. So it works out pretty well. We also get, if there is a failure, we get emails where you can click right through to the logs that failed in the job. So that was beneficial.
Great. So I want to dive a little bit into the architecture of the Kubernetes executor and how it works. There were three main use cases we would have to consider to ensure that the correct result of the task would reach back to the user. The case where the task passes, the case where the task fails, and the case where the pod dies before the task is able to pass or fail. For both the cases of the task passing and the task failing, we were able to take advantage of the fact that Airflow has a single Postgres or SQL in the backend. So because we were able to launch these worker pods with access to the same Postgres instance as the scheduler, the workers themselves were able to report the passing or failing of their tasks, and the scheduler did not have to actually monitor the task health. This would then get bubbled up to the UI where it would be reported to the user, and the workers had the same logic for sending emails or retry policies or anything of that sort. But of course we had to consider the case of when the pod itself, through either preemption or some issue, maybe a machine goes down, the pod running the task dies before the task is able to complete. And to address this issue, we use what's called a watcher thread. Kubernetes has this API for watching where there's a single event log that you can actually subscribe to. So you can, as the scheduler can say, subscribe me to the status of every pod that has the label Airflow-worker, and therefore watch all these pods. And then if it notices that a pod dies in an error, it can change the state in the Postgres instance to report back to the user that something had gone wrong. An interesting problem we ran into was the problem of DAG propagation. So we'd shown earlier how Airflow allows you to set your directed acyclic graphs in the form of a Python file. But depending on the size of your company and the maturity of your Airflow instance, this can be anywhere from a few kilobytes to up to tens or hundreds of megabytes of Python files that have to be propagated out from the scheduler to each of these workers. We address this in three different modes: the Git Init Mode, the persistent volume mode, and we're looking to, in 1.10.1, add in a pre-baked mode where the DAGs are actually baked into the Docker image themselves. We recommend the Git Init Mode and the pre-baked mode for people running small to medium-sized Airflow instances, purely because these are the simplest ones to set up and the easiest ones to maintain. But for cases of companies with very large-scale deployments, we also offer a persistent volume mode. And persistent volumes are actually a native feature in Kubernetes that allow you to take something like NFS or Seth or other distributed file systems and treat them as if they are a local directory in your image. For the architecture of the Git Init mode, we use something called an init container. And the way that works is that when the Airflow scheduler requests a worker be created from the Kubernetes API, it actually first gets launched with this shared folder and the init container that only pings GitHub to receive the DAGs, and then once it's received all those DAGs, is able to shut itself off, and then Airflow starts up with the DAGs in the correct folder as if they had been launched with the image. And finally, we had to take some consideration into fault tolerance. Kubernetes has a very strong philosophy of trying to make applications as stateless as possible. And we wanted to kind of work around that. Some of Airflow's internal architecture involves using shared queues and other local data structures that, if the scheduler goes down, run the risk of either losing data or repeating jobs that had already been run. So we were able to use something in Kubernetes called a resource version. We had mentioned earlier that there was a watcher API where you could actually read all of the event logs for what happens in your cluster. So the resource version is actually monotonically increasing. So if you know the last resource version that the scheduler was able to register, then you know where, and the scheduler goes down and comes back up, you know where you need to start and reread the logs from those points to ensure that you're up to date. So we added a resource version SQL table into Airflow that every time the scheduler reads one of these Kubernetes watcher events, it writes that to the resource version, thereby making sure that if it restarts, nothing will get run twice and nothing will never get run. As for the current state of the Kubernetes Executor, the Kubernetes Executor is in the process of being released in Airflow 1.10 as experimental. We're still very actively working on it, but we have had multiple companies, including PubNub, run the Kubernetes Executor in their production clusters. We have a Helm chart in process, and we have a very active community on the hashtag SigBigData channel on kubernetes.slack.com. And we have time for, do we have time for a quick demo? Perfect. Oh, before. Okay, perfect. So I've set up a quick demo. Let me switch this to mirror mode. Sorry, let's see. Great. So I actually have an Airflow deployment as well as Postgres running in a Minikube cluster right now. We are currently working on releasing Helm charts, but you can actually, in the Airflow source code, see setup Kubernetes deployment that we've created for our integration testing. But if I port forward the 8080 port from the Airflow deployment, that will give me access to an Airflow, to the UI for an Airflow instance. Now, this is where the Kubernetes Executor and the dynamic allocation comes into play. Let's say I run the example Python operator, which is a DAG that will launch about 5 different pods at the same time once the print the context function has been run. So I trigger the DAG, I go back here, and I can actually set a watch to see when new pods are created. So as soon as the print the context function is completed, it attempts to create all 5 of the sleep functions, and then once those sleep functions have been created, it will then return to its original size of just the Airflow scheduler and web server and the Postgres instance. And you can actually watch all this also take place in the UI, and the job has been completed. So what's next for the Kubernetes Executor and KubernetesPodOperator? One big thing that we're looking to add in for future deployments is the idea of throttling. The Kubernetes scheduler is naturally very greedy. Even if the scheduler is being slammed and it has no capacity, it will continue to take on jobs as long as you continue to request them. For now, we actually have settings for maximum parallelism, so we would leave that to the user. But there are ways that we can essentially check to ensure that if the Kubernetes cluster stops taking in new pods, that the Airflow instance can stop itself and wait till the cluster is in a better state before it launches more tasks. We are also in the process of scale testing. There has been a lot of help from members of the Kubernetes community as well as members from the Cloud Composer team to try to see where we would run into scaling issues with with the Kubernetes Executor. And we're also trying to write some generation scripts to generate large-scale DAGs, just to see at what point the initialization time of the worker pods becomes more expensive than the benefits you gain from the actual dynamic allocation. We are always looking for brave souls that are interested in experimenting with our executor, and we are very interested in any form of bug hunting or beta testing. We are currently active on both the SIGBIG data channel and the Airflow Operator channel on kubernetes.slack.com. I want to give a huge thank you to Grant Nicholas, Benji Goldberg, and Anirudh Ramanathan for helping so much with the deployment of this, and especially to Seth for taking us on and giving us some early production level testing. And thank you, and of course, we are always hiring.
What questions does everybody have?
Yeah, we have like 10 minutes.
Thank you for, hello, test? Yeah. Thanks for giving us that overview. One thing that maybe I just missed, but could you clarify, is when your executor launches some more pods to do the work, are they running Airflow too, or are they like your own custom Docker images? And if that, then how do you maintain like the codes and the build for those bits?
So the pods that are created for the workers are actually running Airflow. So it's the same Airflow deployment that the scheduler is running. The only difference is that rather than running the Airflow web server or Airflow scheduler command, it will run Airflow run and then the DAG ID and the task ID. So when you launch a pod in Kubernetes, you can give it a command, and Kubernetes will know to run that one command and then terminate once that command is finished.
And there's no scheduler?
Yes.
Go in the back.
With regard to DAG versioning, do you guys have any problems with individual DAGs being version changing while things are happening, or have you addressed that at all?
So, not really. We haven't run into it. I think one of the early things that we were warned about is if you were to change the code on a already running worker pod, then it would actually pick up the changes while it's running, I think was an issue. But because the way it works with the init container is it will, at whatever point in time, for us, what we do is we put changes into a branch, and then it goes through our build system, and then somebody has to accept the pull request. And from that moment on, any new runs of that pod will come up. It will pull the latest changes from master from Git, and it will run just those changes from that point on. So really, there's no problem of it changing in the middle, but there can be, if you're rapidly changing, sometimes to make sure that like, okay, what version do we have currently running in the pod? But for our case right now, that hasn't really been too much of a problem.
And are you primarily dynamically generating DAGs or writing them manually?
Yeah, we're only using the Kubernetes Executor.
I think he's asking if you like generate new DAGs with each release, or if you guys are writing out your DAGs by hand and then PRing those.
Oh, we always write them by hand, and then they have to go through our pull request system. So.
Okay, it looked like you batched some. I was just curious if you had like 100 DAGs that were all going from similar places to similar places that were getting. Because you said you did them all from bash and to DAGs in one day.
Oh, so what we had was a lot of legacy scripts, and these scripts would do things like go pull data from this MySQL table
That's
and
exactly
then move
what
it here.
we did, yeah.
And then that actually becomes a lot easier because there's like already a database DAG or something created, and you just configure it, put in some credentials, and there you go. So some of the changes that we encountered that we couldn't bring forward is we actually used the Kubernetes secret store for a lot of the credentials, and that was a little bit of a learning curve, but we got that working as well. So from then on, Kubernetes is handling all the reliability and the availability of these jobs running, so they wouldn't crash and then have to worry about somebody coming along and restarting them. Yep.
For Kubernetes in the tasks, so are you still using that within like a celery executor, and just some of the tasks are on Kubernetes? I'm not sure if I'm clear.
Are you talking about the Kubernetes pod operator, or are you talking?
Yeah, sorry, that one.
So the Kubernetes pod operator works with any executor. The only thing you need for the Kubernetes pod operator to work is a kube config, so that Airflow can speak to a Kubernetes cluster.
Okay. And what's sort of the overhead on starting that up and cleaning it up?
Very minimal. Once whatever image you are running has been warmed up, so there might be some it might need to pull the image the first time, but once that image has been pulled, it's like a second.
Yeah, if you don't change the image, then typically you can just cache it on the cluster, so it doesn't have to pull it down each time.
There are two over there.
Could you contrast the Kubernetes operator with the ECS operator, if it has like any benefits over it, or like different use cases where you would use one over the other?
ECS?
Elastic Container Storage, AWS, where you can also
Yeah, that's Amazon's.
kick off the Docker containers.
I don't think any of us have ever worked with that one, the ECS one.
Yeah. I've unfortunately never worked at an AWS first company, so I don't have a lot of experience with those.
All right.
Hello. I have a question about dynamic scaling. So you mentioned that you could specify the number of pods and it will spin them out. Sometimes data is too big to fit on a single machine. So does it spawn like multiple instances as well?
So for us, we've never had to go to that level, but yeah, you could essentially put it on an auto-scaling group to have your Kubernetes namespace on an auto-scaling group that would add instances as it goes along. We haven't really had to do that yet, just because we've kept our Airflow slim. All it's doing is making calls usually to Amazon's API. So there's not a lot of overhead in them. We've run probably, I think, up to like maybe 70 concurrent worker pods at a time, and it doesn't really use up that many resources. But you could do it to where we have our concurrency, our parallelism level set to, I think, about almost 100. And then our concurrency for each DAG is set to somewhere, I forget exactly, but you could set that up much higher and then let Kubernetes auto-scale out and add instances as you go along, definitely.
It's also worth noting that best practices in Airflow is to try to keep as much of the actual computation or heavy lifting outside of Airflow or outside of anything. That Airflow should really mostly just be about monitoring and reporting failures and retry policies and stuff like that.
Yeah. So even if you're making call to some other services, that service should be handling the parallelizing task. So it would be like either spawning a Docker container or Kubernetes bots, or spanning multiple instances of.
Yeah, and that would just be depending on your use case, I think, if I understand you. For us, we are launching mostly Apache Spark jobs, but we actually just still run that on Amazon EMR. So what we're doing is just calling out to the EMR cluster, and we say, okay, let's create a job flow, and these are the steps that we want to put in it. And then so Airflow gets back, okay, I have a job flow ID. We wait make sure that that's successfully launched. And then downstream, we're like, okay, let's wait for the results to show up in the place that we expect it. But a lot of that happens outside of Kubernetes itself.
Perfect.
Yeah.
It seems like you're managing a lot of your kind of event tracking on the SQL side, and you're generating a fair amount of data there in addition to the data you're pushing back and forth. Are you doing any kind of like log retention policy to institute how long you're keeping this for monitoring?
From the task history?
Yeah.
I don't think that we do. It's not a very big database. We run, so in production we run we have Postgres backing it. That we run on RDS, so we just let it scale out there. We run a lot on Kubernetes, but we still haven't been running any stateful services so much in production on it. So we just let those things scale there. And I think it actually, it's useful just to keep the whole history of the task. They might clean up at a certain point, but I can't remember for sure.
Do you know if there's any integration between Airflow and Terraform, or these executor for Terraform version?
That's a good question. I've never seen one, but if you go and look at the operators that are out there, they might have something like that that somebody's contributed. We haven't done anything like that, but it could be possible. Yeah. I mean, yeah, maybe.
You showed the logs coming from S3. I believe those logs are only written after the task completes.
Yes, correct.
So do you do anything to make it so you can see the logs while the task is running?
So I think that, and I haven't touched it for a little bit, I think we can actually tail the pod logs while the task is running from kubectl. But some of them are so short-lived that it's only after the fact that we want to go and look at them. But I think it's possible when we just go and grab them from the pod itself. I think they do show up there.
Awesome. Are there any more questions?
I have a question, actually. Have you ever done the trigger DAG? Like, is one cluster able to trigger another DAG? Or are they more
I'm not sure.
So I guess at work we have a couple different DAGs that trigger another DAG. Have you used that in this instance? Would you run into problems like not being able to trigger another DAG with one?
So I haven't personally run into that use case. But that said, if you do run into any problems with that, like we're really, really active on those Slack channels, so you'll get a response probably like within an hour.
Okay, that's it. Thank you.
All right, thank you.